Hi, welcome to Math Fun. Today we are going to talk about why 1 is not a prime. I'm pretty sure many people wonder about that questions. I did when I was younger, as a matter of fact. But why? Why 1 is not a prime? Now, before we go too far, let's talk about what is a prime. What is a prime? So a prime is simple. It defined as this. It defined as a positive integer, or in other words, a natural number that is divisible only by itself and 1. For example, 2 is a prime because 2 can be divided by 1 and 2 and nothing else. So by definition, 2 is a prime. Now, 11 is also a prime because 11 can be divided only by 1 and 11, 1 and itself. Now, 20 is not a prime because 20 can be divided by, yes, 1 and 20, fine, but also 4 and 5, and in fact 2 and 10, okay? Etc. So 20 is not a prime. Now let's look at 1. 1 obviously can be divided by 1, and 1 is itself. So some people may argue, well, because 1 serves as 1 and itself in the definition of prime, so that's why we should not count it. Well, if you think about in this way, I would say that's just an excuse. And in fact, it's a pretty lame excuse. Why is that? In mathematics, we see situations like this quite often, but we do count them. And I'm just going to give an example. The example is about factorial. So if you forget what factorial is, this is the definitions. You can only use a positive integer again, like n factorial is defined as 1 times 2 times 3 times times until n, until itself. So from 1 to itself, the products of the integer between 1 until itself inclusive. This is the definition of factorial. Now, do we have a 1 factorial? Absolutely, it's equal to 1. So in this case, 1 is 1 and 1 is also itself. We don't exclude it. We actually say it's totally fine in this case. So that's why I said, if you said the reason why 1 is not a prime is because 1 is 1 and itself, that's why we don't count it. I actually will say this is actually a pretty lame excuse. Mathematics usually doesn't work in that way. To be fair, by the way, in histories, many people consider 1 as a prime number. Indeed, that happened. Some people did not, some people did. And the two mathematicians, in fact, can serve as two examples. So I'm pretty sure you know Euler, one of the greatest mathematicians in history, and you may hear about Goldbach. Now, he obviously wasn't as famous, but he was famous because of his conjecture. His conjecture said this: an even number bigger or equal to 4 can be expressed as the sum of two prime numbers. For example, 4 equal to 2 plus 2, and yes, 2's are prime number. Or let's say 10 equal to 3 plus 7, or equal to 5 plus 5. So you can have multiple ways, as a matter of fact. And Goldbach, in fact, considered 1 as a prime number when he communicates with Euler by letters, obviously, back then. On the other hand, Euler did not consider 1 as a prime number. So in other words, some people did, some people did not. It's just more or less a personal preference. However, things change. Fewer and fewer people consider 1 as a prime number. The last publication that considered 1 as a prime number, from what I heard, was about 60 years ago. And since then, nobody considered 1 as a prime number anymore. So you may ask then, if that is the case, what would make it bad if you consider 1 as a prime number? If nothing goes bad, then we're usually okay with that, right? It has to be something not quite right if we do that. And that goes to the fundamental theorem of arithmetic, because it doesn't go well with this theorem. So what is this theorem? It's a very important one, that's why it's called fundamental, and it's really simple as a matter of fact, except this: any integers bigger than 1 is either a prime itself or can be expressed as products of some prime. And that expression is unique. The last statement is also very important. So let's look at some example. So 5, okay, 5 is a prime, so satisfy the theorems. Now how about 6? Well, 6 equal to 2 times 3, and that is the only way to write 6, 2 times 3. Now 3 times 2 would not consider as a different way of expression because those are trivial, okay? So just switching the order, the prime would not consider as a new expression. So in this case, there is only one way to do it. Or we can have another example like 20. 20 equal to 2 times 2 times 5. So that's what this theorem is all about. Now, why this one have anything to do with 1 not be able to serve as a prime? Because if 1 is a prime, then we still pick 20. 20 can equal to 2 times 2 times 5, right? So that's one of the options here. But we can multiply by 1. Still the same. Or if you want, you can do 2 times 2 times 5 times another one, or even another one, as many as you want. So that means the expressions of a number to be products of multiple prime is not unique anymore. And that doesn't go well with these theorems. Now, it doesn't mean that we have to abandon it if we consider 1 as a prime. Now, we need to say in a different way, though. We have to say that, okay, a number bigger than 1 is either a prime itself or can be expressed as products of multiple prime that are bigger than 1. And that expression is unique. Now, don't you think this is a little bit more difficult to state the theorem? And that's why it makes much more sense not to consider 1 as a prime and make our life easier. And that's the reasons, the most important reason at least. And that's all for these videos. If you like these videos, please make sure you like and subscribe. Thank you very much for watching. Bye bye.